Hello, everyone. We're here today to present to you our idea of the claw. So, when completing extravehicular activities, EVAs, or commonly known as spacewalks, astronauts face many challenges, particularly in their bulky equipment, specifically their space gloves, which can be challenging and uncomfortable. National Geographic has identified hand injuries as the number one nuisance in space. These long, maybe often 6 hour spacewalks often lead to hand/grip strain, fingernail loss, frostbite, and when completing these tasks in space gloves, astronauts can face a lack of precision, prolonged task length, and overall frustration.
Therefore, we created the Comprehensive Lightweight Astronaut Workhand, or the C.L.A.W. As you can see, it's very hard to pick up small objects just in standard winter gloves, let alone the oven mitt type gloves that astronauts must wear in order to keep themselves safe. So we created this tool that attaches to the back of an astronaut's arm and is able to easily pick up these objects with a very simple pull of the finger mechanism. This has very few points of failure. However, it does still require the astronaut to close their hand like normal, so we thought that there might be a better way to assist these specific cases. So we created this higher fidelity model. This one is controlled by an Arduino, which requires no movement of the hand. In this case, you can see that I am pressing a button, but in future cases, we would most likely switch to some kind of voice activation method, which would allow complete hands-free use of the claw, and it would allow it to hold on to the object for extended periods of time with no additional strain to the astronaut. As you can see here are some models of our claw and different ideas for the future. I mentioned the possible voice activation. We're also looking at different forms of the grip head, improving the straps and the attachment, especially integrating it with the spacesuit itself, and making the head modular and specific for certain task needs, as will be addressed in our user interviews.
Through developing this product, we've been able to talk to many knowledgeable people on the subject and have gotten a lot of good advice from them. This includes Dr. Barrett Caldwell, a professor here at university who is in industrial engineering and aeronautics and astronautics, Al Holland, a former NASA psychiatrist who has trained with many astronauts, and a former astronaut, Andrew J. Voicewell, who has performed over 9 EVAs. And a part of our user testing, one thing that each of them primarily talked about in their discussions was they wanted functionality and simplicity in our product, making sure that the claw could function, but at the exact same time still keep its functionality fairly simplistic and not overcomplicated for others. On top of that, from our interviews, Dr. Caldwell gave us the main advice on voice commands and hands-free usage of the claw. So that way there wouldn't be the complications of using both hands at once while using the claw. On top of that, the complexity of the claw came into mind when discussing the possibility of using the claw in different markets, having a high fidelity and a low fidelity model that could be used for either astronaut usage or for an additional market that he discussed, uh, people with dexterity issues. So that way it can be used by them and primarily have less of the complications that would be needed for astronaut missions. On top of that, Voicewell's advice was to use the claw for additional functions other than just grabbing. Like it could be used for drilling functions or even sometimes doing loops within certain motor functions. And for individual on the ground use of the claw, he proposed the idea of making a simulated vacuum sealed cube that could help give a feeling of the claw and overall show its usage while even on Earth. And for in general, everyone voiced the idea of putting in a lot more research into making sure that the claw itself could fit well on the astronaut suit and be integrated within it without being overly rambunctious in its design or just overly pronounced. And on top of all of that, they all spoke very positively about our product and thought that it would be used very well within astronaut capabilities.
Piggybacking a little bit off of the use in people with low dexterity or just in general geriatrics, We made a financial projection for if we were to use this product in that field. Here are the financials. Years 1 and 2, we are not net positive. Years 3 through 5, we are. Additionally, we would hope in year 5, we would be able to sell this product to NASA. That process in the past has netted people on a conservative side $150,000 to $300,000. We would use the funds that we gain from selling this in the geriatric field to improve upon our NASA product, and hopefully work with the NASA more in years 6 and beyond.
Of course, like Henry mentioned, our end goal with this product is to get this to NASA or other aerospace companies. We see, especially after confirming our ideas with experts in the field and professionals, we feel that there's a huge future for the claw as humanity turns to space as the next frontier for both colonization and resources. We believe a tool like the claw that enables astronauts their full dexterity without any issues will be crucial towards moving to that final frontier. Like we mentioned earlier, we plan to leverage resources within the aerospace industry to, of course, put the claw not in, but on the hands of every astronaut. Thank you so much for your time and tuning into our presentation. Once again, we are the Claw.